Evaluate a definite integral between -1 and 3 of this polynomial right here. Now, what we do is called the fundamental theorem of calculus. All right, you take the integral, you find whatever that is, okay, and capital F stands for integral, and then what you do is you take, this is called the upper limit, and subtract the same exact integral and plug in the lower limit. This is the fundamental theorem of calculus, the FTOC. All right, so the first thing I have to do, as I erase that, is I have to take the integral. No plus c's in this. We are finding absolute answers. All right, you're taking the integral of negative x to the third plus 3x squared plus 1. So a lot of power rule going on here. So we have -1 over, take that 3 plus 1, x to the 3 plus 1, plus 3 over x, which is 2 rather, plus 1, x to the 2 plus 1, plus, if it's just a constant, when you take the integral of a constant, attach an x. And then these little things over here are just reminding me that I have these limits of integration that I'm going to eventually plug in. So let's clean this up. -1/4 x to the 4th plus 3 over 3 disappears, x cubed plus just an x with my limits being 3 and -1. Now the fundamental theorem of calculus says is I'm going to take this whole thing, plug in 3, minus take this whole thing, plug in -1. So a little bit of math. Hopefully I saved myself enough room. I feel like I didn't, but I guess we'll find out. -1/4. My upper limit is 3, so 3 to the 4th plus 3 to the 3rd plus 3, close it, minus -1/4. -1 is my lower limit to the 4th plus -1 to the 3rd plus -1, close that. All right, let's see how much math we can do and not make any silly mistakes, which is bound to happen. Bounds, that's funny. Math humor. Math humor. All right, we've got -1/4 times 3 times 3 times 3 times 3 is 81. So -81/4, don't like that, plus 3 to the 3rd, which is 27, plus regular 3, which is regular 3, minus -1 to the 4th, which is regular 1 times -1/4, so -1/4, plus -1 to the 3rd, so -1, plus -1, so -1 again. All right, let's change colors. All right, so I'm just going to use decimals because that's probably the easiest way to go. That's -20.25, right? -20.25. This guy becomes 30, so -20.25 taken away from 30 is 9.75, minus -1/4 minus 2, so -2 2.25. All right, double negative becomes a positive. 9.275 plus 2.25 is going to give me a nice 12. And that's the fundamental theorem of calculus for you. Can't spell fundamental theorem of calculus without fun. Oh, the answer is 12.